In this video, I'm going to review with you how to do some simple math operations in VPython and how to code it. Now, VPython has a really nice set of help pages. Let me show you how to access those. So if you go to glowscript.org, right here, and then you just click on the Help tab right here, you can see that there's all kinds of drop-down menus here on the left-hand side that you can choose how you want to know how to code, what the syntax is like for doing that operation. So, for example, you can figure out how to do any shape. It'll show you how to do any shape here, right, and what the coding is like for that shape. But what I'm going to focus on today is how to do some simple math operations. And so that's down here under Math Functions, under Work with 3D Objects. And so this shows you a whole bunch of different math functions, and we'll go through them. But it doesn't go through the super basic stuff, and so I'm going to go through all of that with you. So if you want to, a good way to practice is to use your VPython to do the math in your homework, and that's a really clever way to get some practice in without having to do a lot of coding on your own. Okay, so I created a program called Doing Math that I shared with you. The link for it is right here underneath the help page link, okay? And so I'm going to be referring to that code and sharing that code with you in this video. So basically what I've got here are excerpts from the code that shows you within the code how to do the math. Now remember in VPython that if you want to comment out a line, which means you want to put in some text to help guide the person that's looking at your program without VPython worrying about that text, then you use a hashtag. And then after the hashtag, VPython will ignore everything else on that line, okay? So I use those hashtags a lot in this code to help you out. Now, if you're going to add, then of course you use the plus symbol, okay? One trick that people often mess up on is remember that you add scalars to scalars, and you can add vectors to vectors, but you can't add a vector to a scalar. That has tripped a couple of students up on some code, okay? So if you get an error message returned to you and you're trying to add a vector to a scalar, that's why. So we're going to use print commands in this code to show you how to use multiplication, division, and all that good stuff. And so remember that for a print command, VPython will then print out whatever it says to print. If you want it to print text, then you put the text inside of quotation symbols. So then VPython will just blindly print out whatever I put inside this quotation. Without quotation symbols, like as is shown here, it will print out the math operation. So for example, for this 2 plus 3 bit, it'll print 5, okay? So that's how that's going to happen. So this is how you add. You just use the plus symbol. Same thing for the subtraction. You use the minus symbol, which is the short dash. And so 3 minus 2 equals, and then this is how you would enter it, 3 minus 2, comma, and then it's going to return that. So let me now run that code for you that I've got under Doing Math, and you'll be able to see it. So let's see. This is my code, okay, right here. And so you can see I have all kinds of math operations that we're going to go through. But for now, let's just look at what VPython returns for my first few statements there. So it returned 2 plus 3 equals 2 plus 3 equals, and then it returned 5 for 2 plus 3, 3 minus 2 equals 3 minus 2 equals, and then it returned 1, okay? So that's how those print statements work, and that's how you add and subtract in VPython, all right? Now, next, if you're going to multiply, you use an asterisk, okay? So this is for multiplying numbers or multiplying a number times a vector. So if you want to say triple the length of the vector, then you would say 3 times the vector, okay? And so this is pretty straightforward. You just, 2 times 3 is going to be 2 asterisk 3, which is equal to, and then it's going to return 2 times 3. Now, dividing, you use that slash, okay? That slash right there. So here, 3 divided by 2 equals 3 slash 2 equals, and then it'll return 1.5. All right, I'll show you that in a second. Now, raising to a power is a little weird. Students often screw this up. You don't use the caret symbol, okay? You don't use that. Instead, you're going to use 2 asterisks next to each other. I know it's a little strange. Most of you are probably used to the caret. But we're going to use 2 asterisks for raising to a power. So for example, if you wanted to square 3, 3 to the power of 2 would be 3 asterisk asterisk 2, which would equal then 9. Okay? Now for square roots, you could either do a power of 1/2, of course that's the same thing as the square root, or you could use SQRT and then inside parentheses whatever you want to take the square root of. So the square root of 32 would be squirt 32, which is shown there. So let me run that now in VPython for you. If you run that in VPython, then it'll return 5.65685 for the square root of 32 there. Okay, so that's what the VPython code returned for my doing math for those things. Okay. Now, trigonometric functions, remember that in VPython, it conforms to SI units. So SI units for angles are radians, not degrees. So VPython, the default will be radians. Now you can make it work in degrees if you force it to, but just be aware that if you put like cosine 45, it's not going to return cosine of 45 degrees. It will return cosine of 45 radians, which is not at all the same number, okay? Now, if you wanted to find a sine, cosine, tangent, something like that, then it's pretty straightforward. I think you would guess this. It's sin and then parentheses, whatever you want to take the sine of, cos, and then parentheses, and then whatever you want to take the sine of in the middle there, and tan, parentheses, with whatever you want to take the tangent of in the middle there. So that's how you do sine, cosine, and tangent. Inverse sines, cosines, and tangents, you put an a in front of the thing, and that is like a sine, which would mean that it would return the angle that would give you that value, okay? Now, another fun thing is that VPython will return pi for you. Pi, lowercase pi, is protected in VPython, and it will recognize that as 3.1415927, okay? So if you tell VPython to print pi, it will return what it says for pi, okay? So here's how to do cosine of pi over 2. It's cos of pi divided by 2. That'll give you the cosine of 90 degrees, right? And then the angle that gives you 0.707 for cosine is a cosine 0.707, and then it would return that. So let me show you what happens with that. It's a little peculiar. Okay, let me show you this. So first of all, if you tell it to print pi, this is what you get. So that's how many digits it's reporting and keeping there for pi, 3.14159, okay? Now that does do some interesting things because it truncates the digit a little bit. So remember that bit where I said finding the cosine of pi over 2? Okay, we all know that the cosine of pi over 2 is 0, right? But because it only kept out to, let's see, what is that, 5 decimal places, then it doesn't quite return 0 for cosine of pi over 2. It instead reports a really tiny number, okay? So just be aware of that. Now, in the work that we're going to do in this class, that's close enough. It's totally fine. And there's ways to work around that if you do go further with it, but for now, we're just going to go with this and say, you're good here, okay? And then here's how to do the inverse cosine. And yet again, it's not going to give you 45 degrees. See, the default is radians. So this isn't radians, the decimal form of radians, okay? Now, speaking of that, you can convert really easily with some commands within VPython from radians to degrees and back again, okay? If you want to convert an angle from degrees to radians, then you can use the function radians or degrees. And then in the argument of that function with the parentheses inside there, you just put whatever you want it to convert. So if you want to know what 45 degrees is in radians, then you would do radians 45. And if you want to know what pi over 2 is in degrees, you would go degrees pi over 2. Okay? So that's what it does here in the next couple of lines of the code. All right? And if you want to, you can then use that to be lazy when you're coding angles. So if you don't want to convert it first, so here I have print. If I don't want to convert and I want to calculate the cosine of 45 degrees equals cosine radians of 45 degrees, and then that would do it for you, and you wouldn't have to do the conversion. Okay? So that's kind of nice if you feel like being a little lazy. So Here's what VPython code returned for that. 45 degrees in radians is radians 45, which is 0.785. And you can see that, of course, it's the same thing of a cosine of 0.707. That's 45 degrees, right? So I get close to that within rounding error. Pi over 2 in degrees is degrees pi over 2 is 90. And there you go. And if I don't want to convert and I want to calculate the cosine of 45 degrees, there you go. And that's what you get. Okay? So that's by no means an exhaustive list, but I think it'll help get you started. And remember that there's that help page. So if you want to learn how to do something else that I didn't go over today, like say exponents, e to the x, there it is, logarithms, natural logs, all kinds of good stuff there, then you can look those things up. Okay? So this help page is there for you. Okay, I hope you found that helpful. Let me know if you have any questions, and as always, I'll see you in class.